Hi, welcome back. In this video, we're going to talk about solving linear inequalities. Now, this entire unit will be about solving inequalities. We're going to be talking about quadratics, absolute value, and linear inequalities, but this video specifically will be about linear inequalities, which will be the foundation to what we're going to be getting into. Now, as usual, we're going to be doing a few examples, and the complexity of these examples increase, right? So feel free to fast forward or slow it down, pause, take notes with me, and let's talk about it. So what is an inequality? Well, these are the different inequality symbols that we've seen, or that you have seen in your math classes, right? They express a range of values, which will now be solutions. As opposed to our last unit, right? We were looking for x equals something. Sometimes you had two answers, or even three, right? When we dealt with like plus or minus or something, right? So we were looking for how do you find the solution of a line, a quadratic, or a cubic function, right? Well, here we're going to focus on the inequality behind those functions. So what does that mean? Well, instead of it being a specific value, we're not just looking for x equals something, we're going to be looking for x equals a range of those values. And I'll show you an example here. Let's get to it. If you are not currently subscribed and have not liked the video, this is a great moment to do that. Okay, so let's start. This example on the left. Here I have an inequality. 3x minus 3 is less than 6. So we're going to treat this as if it were an equal sign, right? All the rules of solving for x will apply. So we're going to isolate the variable by moving the 3 to the other side. That gives me 3x less than 9. And then when I divide by 3 on both sides to isolate the variable, we get x is less than 3. So, if we recall, less than and greater than symbols have open circles. Less than or equal to and greater than or equal to symbols have closed dots or closed circles. Here we're dealing with everything less than 3, which means at 3, we will not include the solution at 3, but we will include everything less than 3. And we shade everything below that. What does this mean? It means that any value less than 3 will make this original inequality true. Let's try it. Let's plug in 0. If I plug 0 in here, we have 3 times 0 minus 3. Is that less than 6? Well, 3 times 0 is 0. 0 take away 3 is negative 3. And negative 3 is less than 6. What happens if I plug in 3? Well, when I plug 3 into the equation, 3 times 3 minus 3, is that less than 6? Well, here we get 3 times 3 is 9. Is 6 less than 6? No. 6 is equal to 6. That's why we don't have the equal symbol here, right? The problem is a less than. For what value will it be less than 6? And it's everything not including 3 and below. And if you chose a value higher, like 8, if you plug 8 into the equation, here's what would happen. If I plug in 8 here, we have 3 times 8 minus 3. 3 times 8 is 24. 24 minus 3 is 21. Notice how 21 is not less than 6. That's why it's not part of my solutions. So a solution, when you're dealing with a linear inequality or an inequality in general, is a range of values. This is my solution set, right? All the values. It's not just x equals something. It's x is everything below this range of numbers for this scenario. Now the solution can be expressed as an inequality, or it can be expressed as a graph, right? Solutions describe for what values is this true. Now I'm going into very detailed specifics about this kind of question, even though It's a rather simpler problem because I want you to understand the idea behind it, right? A solution can be expressed as a graph or it can be expressed as an inequality. And both notations are telling me for what range of values will this original inequality be true. Now we're going to take the same philosophy and apply it to a few more examples. So we're going to combine like terms, simplify, and solve for x, right? That's the idea. Here I'm going to distribute the negative inside. I have 7 is less than positive x, positive 3, plus 2. We're going to combine like terms now that this is simplified a little bit. These two give me 7 is less than x, positive 5. And as I solve for x, I can move the 5 to the other side. X and 2. Now, how do I read this? From left to right, this says 2 is less than. This says less than. I wrote less than. But this is less than. 2 is less than x. What's another way to say this? Well, if I read it from right to left, what I'm really saying is x is greater than 2. So if you rather read where the variable's on the left, just flip the sign and move things to the other side, right? From the right side, we would say x is greater than 2. Are you able to interpret this version or this version better? They mean the same thing. I prefer this one. X is all the values greater than 2. Now, since there's no equal symbol here, it's going to be an open circle, and we shade everything to the right. Right? X is everything greater than that. And you're welcome to plug in numbers in the different ranges to see what is true. All right. Notice how these examples are a little bit more complex than these, right? The idea is to understand the philosophy or the theory behind what we're doing, and then we can apply it honestly to any problem. So we're going to be able to apply this to quadratics, to absolute values. We can apply this to anything we want, even cubics, right? So let's start with this problem here on the left. Okay, so I'm going to distribute. I got 26 plus x is greater than or equal to negative 30 plus 15x. All right, my goal is to combine like terms as much as possible in order for me to solve for x. So I'm going to move the x to which side? I prefer moving x's to the left because in the end, I want to be able to read the problem. X is greater than something or x is less than something as opposed to the number is less than x or the number is greater than x. So for these scenarios, I'm going to move all the x's to the left. Okay? And I think that's what Beyonce would say too. All right. Let's move this to the left. Minus 15x. You know, to the left. Okay, I'm not going to explain that one. 26 minus 14x is greater than or equal to negative 30. I'm going to move the 26 to the other side. Negative 14x is greater than or equal to, what do we get here? Negative 56. Now I'm going to divide by negative 14 to isolate this. And if you recall back to previous algebra courses, when you divide by a negative, the symbol switches sides. Right? The inequality changes. And we can talk more specifically as to why that happens. But we're saying when we're dealing with a negative, the value is going to be greater than something. But when you're dividing by it, when you're getting rid of it, we're kind of undoing that philosophy, right? We're undoing the process, which means we need to change the direction of the sign. And the negative divided by negative is a positive. So now because there's an equal symbol, I'm going to go to 4, do a closed dot at 4, and shade everything less than. Everything to the left, right? The L looks like the less than, or the less than looks like the letter L, in case you're needing direction, right? Some of us still use our fingers to like, where do I turn? Left, left, you know? So that might help you with the decision of the symbols. We're drawing that way. Okay, here, feel free to pause this one and give it a try yourself. It's still linear. There's no quadratics, there's no cubics, there's no other symbols. It's just a little bit more elaborate, right? We're just going to do a little bit more algebra to get there. Distribute x plus 1, positive 1, positive 6x, right? The signs change. Greater than 3x minus 12. Distribute this one into the other one. Minus x plus 4. When you combine like terms, right? These are like terms. You get 7x plus 2 is greater than. Here I can combine these. 3x minus x is 2x. And then the negative 12 plus 4 can give me negative 8. Right? I'm just combining like terms. It's when I switch things to the other side that I have to change the sign. Right? If it's on the same side, just combine it. It's 3 minus x. But if I have to move the 2 to the other side of the inequality or the equal symbol, that's when I do start doing the opposite. Because I need to be able to balance the equation, or in this case, the inequality. In order to balance it, I have to do the same thing to one side as I do to the other. And it's got to be the opposite for things to cancel. And I got 5x plus 2 is greater than negative 8. I continue to solve. I move the 2 to the other side, so I do the opposite. 5x is greater than, what is this here, negative 10. And then when I divide both by 5, I'm not dividing by a negative, right? It's only when this value is a negative that I flip the sign. This can be negative all at once, but it's what's attached to the x, right? And since it's a positive, the sign stays the same. As opposed to here, I was dividing by a negative, and that was influencing the x in a different direction. So everything bigger than negative 2. It's an open circle because there's no equal symbol, like in this one where we had a closed circle, and it's greater than. Maybe you can remember that it looks like a letter G. Maybe you remember the alligator or the little fish and the big fish, and I don't know, whatever works for you. Everything bigger than negative 2. So I'm going to shade everything to the right. Alright guys, I hope this has helped. Please let me know if you have any questions. Don't forget to like and subscribe. The next few videos will be about solving quadratics and other functions. You guys have a great day, and as always, we'll calculate.